There is a number written into the architecture of the cosmos, and no one signed off on it. It appears in the equations that describe how light travels through empty space, how atomic clocks tick aboard satellites in orbit, how galaxies recede from one another across billions of light years. It is roughly 29,97924 meters per s-econd, and it represents an absolute ceiling on how fast anything carrying information or causation can move through the universe. This number was not negotiated. It was not voted on by any council of physicists. It was discovered slowly and with considerable resistance as one of the most stubborn facts about reality, and the more closely we examine it, the stranger it becomes. Consider what this speed limit actually means. If you were to accelerate a spacecraft continuously, pouring energy into it without limit, you would never reach the speed of light. You would approach it asymptotically, requiring exponentially more energy for each incremental gain, and at no point would you cross the threshold. The universe does not merely discourage exceeding this speed. It makes it impossible. Mass, energy, and the geometry of space-time itself conspire to enforce the boundary. And yet there is no signpost, no physical barrier, no enforcement mechanism we can identify. The limit simply is, woven into the fabric of how things move and interact. The story of how humanity came to recognize this limit begins in the 17th century, with a Danish astronomer named Olimar Remer. While studying the moons of Jupiter from the Royal Observatory in Paris, Remer noticed something peculiar. The eclipses of Io, Jupiter's innermost large moon, did not occur on schedule. When Earth was moving away from Jupiter, the eclipses appeared to lag behind predictions. When Earth was approaching Jupiter, they appeared to occur ahead of schedule. Remer realized that the discrepancy could be explained if light itself took time to travel. The further away Jupiter was, the longer its light took to reach Earth, and the apparent timing of the eclipses shifted accordingly. From this insight, Remer made the first reasonable estimate of the speed of light, off from the modern value by about 25%, but extraordinary for its time. For 2 centuries afterward, the speed of light was treated as a physical property, a measurable quantity, but not as something fundamental. It was simply the rate at which a particular phenomenon, electromagnetic radiation, propagated through space. The deeper significance remained hidden. That changed in the 19th century when James Clerk Maxwell developed his equations describing electricity and magnetism as a unified phenomenon. Buried within those equations was a constant, a specific number that emerged from the relationship between electric and magnetic fields. When Maxwell calculated what that number had to be, it matched the measured speed of light. Light, Maxwell realized, was not just a phenomenon that happened to travel at a certain speed. Light was an electromagnetic wave, and its speed was determined by the fundamental properties of the electromagnetic field itself. This was a profound shift, but it raised an immediate problem. Waves, as understood at the time, required a medium. Sound waves traveled through air. Water waves traveled through water. If light was a wave, what was it traveling through? Physicists proposed an invisible substance called the luminiferous ether, an undetectable medium that filled all of space and through which light propagated. The ether was a desperate hypothesis, but it preserved the classical picture of physics. If it existed, then the speed of light would be measured relative to the ether, and observers moving through the ether at different speeds would measure different speeds for light, just as observers moving at different speeds through air measure different speeds for sound. In 1887, 2 American physicists, Albert Michelson and Edward Morley, conducted an experiment designed to detect the ether by measuring small differences in the speed of light along different directions as Earth moved through space. The expected effect was tiny but detectable with the precision instruments they had built. The experiment found nothing. No difference, no variation, no detectable motion through the ether. The result was so unexpected that it took nearly 2 decades for physicists to fully grasp its implications. Various explanations were proposed, most of them attempts to save the ether hypothesis through increasingly elaborate modifications. The resolution came in 1905 from a patent clerk in Bern named Albert Einstein. Einstein took the failure to detect the ether not as a problem to be explained away, but as a fact to be incorporated into a new theory. He proposed 2 postulates. First, the laws of physics are the same in all inertial reference frames. Second, the speed of light in vacuum is the same for all observers, regardless of their motion relative to the source. These 2 statements seemed innocuous, almost obvious, but their consequences were revolutionary. If the speed of light is the same for everyone, regardless of their motion, then space and time themselves must behave differently than classical physics assumed. The consequences cascade outward. Two events that one observer sees as simultaneous, another observer, moving at a different velocity, will see as occurring at different times. Lengths contract along the direction of motion. Time itself slows down for objects in motion, as measured from a stationary frame. None of this was philosophical speculation. It was the inevitable mathematical consequence of taking the constancy of the speed of light seriously. And every prediction Einstein's theory made was eventually confirmed by experiment, often to extraordinary precision. The global positioning system, on which much of modern civilization depends, must account for the relativistic effects of time dilation in its satellites. Without these corrections, the system would accumulate errors of kilometers per Dalton Y, but the deeper question remained. Why this number? Why 29,792,458 meters per second, and not something else? The answer, as it has emerged through decades of theoretical work, is that the speed of light is not really about light at all. It is about the structure of space-time itself. The speed of light is better understood as the speed of causality, the maximum rate at which any influence can propagate from one event to another. Light happens to travel at this speed because photons, the particles that carry electromagnetic radiation, have no mass. Anything without mass travels at this speed. Anything with mass travels slower. The number is not a property of light. It is a property of the universe. This reframing reveals something profound. The speed limit is not a restriction imposed on motion. It is a feature of how cause and effect are connected in our universe. You could cause an event to happen before its cause occurred. The very notion of cause and effect would break down. The speed of light, in this sense, is what keeps the universe coherent. It is what allows the past to remain past and the future to remain future. It is the thread that holds causality together. There are wrinkles, of course. The universe itself appears to be expanding faster than light, in a sense. Distant galaxies recede from us at apparent velocities that exceed the speed of light. But this is not a violation of the speed limit. It is the expansion of space itself, not motion through space. No information is being transmitted faster than light. Similarly, certain quantum phenomena, such as the entanglement of particles separated by large distances, appear to involve instantaneous correlations. But careful analysis shows that no usable information can be transmitted through entanglement faster than light. The speed limit holds, even in the strangest corners of physics. Yet the question of why this particular speed, this particular number, remains open. The speed of light is what physicists call a dimensional constant, meaning its value depends on the units we use to measure it. In natural units, where the speed of light is set to 1, the question becomes about the relationships between other physical constants. The fine structure constant, for example, which governs the strength of electromagnetic interactions, is a dimensionless number, approximately 1/137th. Why this value? No one knows. These constants appear to be fundamental, not derivable from any deeper theory, and yet they determine the entire character of our universe. If they were even slightly different, atoms would not form, stars would not shine, life would not exist. Some physicists have proposed that the constants of nature are not truly constant, that they may vary over cosmological time or across different regions of a vast multiverse. Searches for evidence of varying constants have so far produced only tight constraints, no detections. The speed of light, as far as we can tell, has been constant throughout the history of the universe, at every place we have been able to measure. It is one of the most stable facts we know. There is something humbling about this. We did not design the universe. We did not choose its parameters. We arrived in it, evolved within it, developed minds capable of asking why it has the structure it does, and we have found that some of its most fundamental features appear arbitrary from our perspective. The speed limit was not agreed to because there was no one to agree with. It is simply how things are, and our task is not to negotiate with it, but to understand it, to map its consequences, to use its predictability to build technologies and theories that extend our reach. What the speed of light ultimately represents, then, is not a limitation, but a constraint that makes the universe possible. Without a finite speed of causation, the orderly progression of events that we call time would not exist. Information would propagate instantaneously. The past and future would blur. and the coherent structure we depend on would dissolve. The speed limit is not an obstacle. It is the scaffolding upon which causality is built. And the more deeply we understand it, the more we realize that the universe is not a place where rules are imposed from outside, but a place whose rules are inseparable from its existence. The speed of light is not a law the universe obeys. It is part of what the universe is. And in recognizing that, we come a little closer to understanding the strange, intricate, and unyielding architecture of the reality we inhabit.